Hello, welcome to another video from Ellensburg Amplifier Repair and Service. This is part 3. This is, yes, 3 parts. A 3-part of a repair. Instead of making one big long video, I'm going to make shorter videos because I personally don't even want to sit around and watch a 45-minute long video. I like to get to the point, get to the topic, get it done, move on. So, took me about 15 minutes or so, not even that, really, to get all those 640Ns back in the output section here. Everything, of course, before I put them in, I verified, I think back on video 1 or so, the gate circuits were still fine, 24K, 25K. And I went over how I determined what the pull down value should be, so I knew I was okay to put transistors in, especially after firing up the power supply and nothing blew up, which is good. So we finished the power supply, verified the function of that, and now we're just going to verify the function of the output section here. And what I'm going to do is I am going to go ahead and get ready, I should say, my 50 hertz input signal. I'm not going to quite, because what do I do first? I always check and make sure I don't get hot. We don't ever want to get hot. You're going to have, thermal runaways. If you're really not watching temperature and you first fire up an amp, you never know when you're going to have thermal runaways. So I use thermal imager. Once I'm done putting things together, and after I do my measurements, my resistance measurements, which I've already done, like I said, my pull down values are where they should be on the output section. So now I'm just going to go ahead and power this thing up. You'll see up in the corner there, the scope is active. So I'm just going to briefly just power things up here just to make sure nothing pops at me. Let's insulate the board. Why do I insulate the underside of the board? One day, little story here. One day I was working on an MD, I think it was an MD 12K, on my mat. I powered the thing up and the thing literally just blew up on the table. No, I mean, I did all my normal checks. Come to find out, I had a piece of wire on my mat. Just a small, minute piece of copper wire. That was shorting the rectifier. And that's what blew up. So now anytime I'm dealing with high voltage, I always raise the board off. You can see right there. You can see. But yeah, I raise the board off the mat so it doesn't blow up in my face. Because I don't like it when they blow up in my face, personally. They're loud. They make the place stink. So right now I'm just verifying that I don't have any heat. I do have the 12 volts on. Let's go ahead and power this thing up. Do I have? Oh. Helps if I connect my remote wire, which has come disconnected. Oh, sorry guys. Here we're waiting for the big reveal. I was like, wait, I'm not seeing any heat. Let me check this again. I have seemed to have come apart here. Okay. All right. Okay, do we have heat? There we are. So just that little bit, I'm just building up a little bit of rail voltage. I don't know, you guys want to see that? I'll show you. So I'm on the gate of the power supply. What I'm doing is I'm watching my rail discharge resistors, because that tells me I have voltage. And if I don't see any heat on the output transistors, those guys right there, then I know I don't have any shorts. At least right now, I don't have any shorts in the output. It looks like I'm good to go ahead and fire this thing up. My discharge resistors are getting nice and warm, as they should. Let's fire this thing up. I don't see any heat There it is. We have a relay. Show you guys, if I can. Somewhere over here we have, oh, there they are. Nice and cool. As you guys heard, the relay kicked on. Let's go over here and see what is going on in the output section. So I'm on the gate of the high side. Relay's on. Oh, hey, and there it is on the scope there for you guys. So you can see there's your output switching. I call it output switching. Others may call it something else. I call it output switching. It's rail to rail. You can see here, just based on that, we are rail to rail, peak to peak of 166 volts. Now remember, that's peak to peak. Your RMS rail to rail is 78.6 volts. Now, why do I say that? That's a good number to keep on hand to actually record. I have 12 volts going in, and I have a pre-filter rail to rail of 78.6 volts. And now we have to verify the preamp. So we're just going to go ahead and hook up the RCA jacks here. I'm going to give it a 50 hertz signal. As always, I am going to move this to the output terminal, which is going to be this wire right here. This is a full bridge, this is a half bridge amp, so your common speaker terminal is tied to common, and the relay is activating the positive side. So we should see, I'm going to back this down because I know that at my 1.5 volts RCA input, I'm not going to have a very high swinging signal. So we know we're not overheating. Now we just need to verify that our preamp is good. Make sure all your potentiometers are fully counterclockwise. You don't want to power up an amp and be in a full-blown clipping. You never know what would happen to the output section. So I will briefly, I'm not on slave, right? We're on master. We should be good to check. And there's your output signal. So 51.5 hertz. Yep. I know, my Heathkit, I run the IG, what is that? The 1272 signal generator. I love Heathkit. I've been building Heathkit for a long time. I like them because it's serviceable. And my frequency is at about 51 hertz. I'm not calibrated to be exact. This is not an exact science. So we do 51 hertz coming out. We have a peak to peak of 11.2 volts at 1.5 volts RCA input at 0 gain. Not bad, not bad. You can see, let's go ahead and zoom in on this just a little bit. There's the output sine wave there for you, if you're interested in looking at the peaks. So there's the top of your output sine wave. Right there. So there's the top. And you can see that there is no noise. No noise in that output section. And that's what I look for. Just because an amp is up and running and you have whatever it is frequency coming out, let's say you have a small, let's say you're testing with a small component speaker. You probably will have a hard time hearing any switching noise at the top. I point backwards. At the top of the sine wave, you will see that top have a bunch of triangles going through it, and it depends on how bad the noise is, depends on the amplitude of the of the messiness of that sine wave. But that's what I look for. So this amp is good to slide back into the heatsink. Of course, you know, replace your thermal paste, keep on top of that thermal management, and your amplifiers should last quite a long time. This will get put back together. It'll go on the load bench, which is right there. So I got amps on top already. Going through a 4th order. I have that set up to where I can go between 1 and 2 ohms, or I have my immersion load bank in the bottom of that, which can handle up to my 30,000 watts. Yeah, interesting setup. Not recommended for your DIY person. But yeah, so that is the completion of this board, functionality wise. And if you got any questions, please leave them down below. If you have any tips, tricks, comments about the videos itself, it'd be great. I'd love to hear from you guys. I love to interact. And yeah, another great Ben's Ruthless amp here is ready to be tested. Well, once I get it put back together, and we'll get it sent out. So thanks guys for watching, and as always, stay safe. Keep your fingers out of the rails. These things can get spicy and give you a bad day. So don't touch these. Well, just don't be grounded. So, alrighty guys, we'll catch you in the next one. Thanks for watching.